All right, so let's go ahead and so I want to remind everybody about the midterm. It's coming up. Oops. Get that in a minute. And let's take a look at what I have so far. Oh, that's not it. Sorry. It's in here. So these won't be exactly the same problems. Or maybe a few of them will be exactly the same problems on the midterm. But they'll be similar to these. So I'm going to use what we're developing here that I'm showing you. I'm going to use that to write the midterm exam. Can someone dim down the lights in some way to make it easier to look at that? Unless it's okay the way it is. I can't tell. Is that all right? No, that's too dark, right? Okay. So here are two problems, which would be typical of the kind of problems that I would come up with. 9 and 10. I just tacked these onto the list. And what I'd like to do is what we did last time, is just start to solve these problems in class here. Just pretend that you're taking the midterm. And let's do number 10 first, okay? Is that all right? 10 first? Because it's shorter, it looks easier to read. Let's look at number 10. Write a C++ program that prints every odd number between 5 and 55 inclusive. Inclusive means include 5 and include 55 when you print the list. And you don't need to include the main. You don't have to put the main function in there. Just give me the code. And if you have a syntax error in the code, that's okay. Mainly I'm looking for the concept of the variables getting declared, the loop expression, the operation that you need to perform. Mainly I'm looking for the logic. Like, see what I did here? They call this pseudo code. It's not real code, but it shows the solution. It shows the algorithm. So I want you to show me the algorithm to print every odd number between 5 and 55. So let's do that. Let's suppose we want to use a for loop. Here's the number. Start at 5. Well, 5 is less than, I is less than or equal to 55. Then we put something in there. How's that? Well, we have to change, but I is not changing. So here we just do I is I plus 2. That'll do it, right? That's the for loop approach. See, I think the while loop is easier to understand. That's why I'm going to do that. While, first of all, you have to have the declaration of I, make it 5, and then while I is less than or equal to 55, we're going to print I, and then we're going to increment I by 2. Which one is easier? See, the thing about the for loop is it's a little confusing to read. This is done once before as you enter the loop construction. This is done at the end of the loop code. This is only done once. This is done repeatedly every time you pass through the loop instructions. But it's done at the end. And this condition is what's tested. So if that condition is false, you do not enter the loop code. You just carry on outside with the statements that follow the loop. So this is more compact. Look at this. Here we have essentially two lines. We've got the for and we have this print. But the while loop, while we have our initialization here, we have the condition for the loop, and then we have two lines that are executed in the body of the loop. So this is, the for loop is a more compact expression of this. They're the same thing. See this, I equals I plus 2, that's done at the end of the loop. So here it is, I equals I plus 2, it's done at the bottom of the loop code. And this initialization, I equals 5, that's done before entering the looping. It's only done once. We don't loop on that. And this condition here, this is the condition that's tested that decides whether you execute the loop code or not. You see the equivalence between these two expressions? And this here, don't get too used to, I plus plus or plus plus I. That's, this is just a statement. You can have any statement in there, like this statement. But normally, for this kind of a problem, I mean, it's up to you, really, what you think is easier, but I think that's easier to look at. A question?
For the while loop, why is that I equals I plus 2 underneath the print?
Why do we do after the print?
Yes.
Because we want to print 5. Because I said print every odd number between 5 and 55 inclusive. So that means I want when the thing prints, I want it to look like this: 5, 7, 9, 11, 13, like that. So it's got to print here. It's got to print 5. So if I put I equals I plus 1 first, then it's going to print 7. Doesn't look so hard now, does it? I know it's hard to get going on this. I'm trying to jumpstart all of you, like starting the car with a dead battery. I'm trying to get you moving, because once you get it, it's pretty straightforward. You can just crank it out. Just break the ice and start figuring out how to do these. All right, let's look at this one's a little longer here. Let's look at 9. There's a lot more to read there. Maybe what I'll do here is I'll give sample code and then have you finish the program, something like that. So write a C++ program that adds a sequence of integers entered by the user. So the user is going to enter a sequence of integers. So he's going to print 5, enter, 11, enter, -4, enter, like that. As long as the user enters a positive integer, the program adds the integer to the running total. We say a running total. As soon as so let's just check for a second and make sure we understand that. What does that mean? So the user enters 2. We have a running total. We set it to 0. So the user enters 2. Oh, okay, we add 2 to the total. Then the user enters 3. Oh, then we're going to add 3 into the total, so now the total's 5. Then the user enters in 11. Oh, so we got to add 11 into the total. Now we have 16. So each time the user enters in a number, we merge it into this total. As soon as the user enters 0 or a negative integer, the program displays the total of all numbers entered. How about the program displays the running total? That's easier to read, right? The running total. I'm not going to worry about that detail. And terminates. Right? So the user types in 2, enter. 3, enter. -5, enter. Is going to print 5, and that's it. You think you can write that code? Do I need to explain any more? Do you think the way it's expressed is okay? Okay, let's do that one. Let's do this one. For people who haven't been here, that didn't come to the lecture, here's one solution that uses the do loop. We declare an integer I, that's the value that the user enters numbers and that the program stores those entered numbers into. Then we have the running total. We initialize it to 0. That's very important. We do not need to initialize I here. And then the do loop is we want to repeat these commands until while we'll repeat those commands while this condition is true. So while the value that the user entered is positive, we'll continue with these loop commands. And what we do repeatedly is we enter in a value through the standard input stream, which is by default the keyboard. So the user's entering these values through the keyboard, being stored in I. If I is not a sentinel value, if it's not a negative number or 0 to trigger the end of this calculation, then we add I into the total. Remember, this is assignment. The thing that's on the right is stored into the thing that's on the left. So the thing that's on the right is an expression. We take what's in total now, we add I, and then the result is stored into the variable that's on the left of the assignment operator, which looks like an equal sign. But it's not an equal sign. It's an assignment operator. You got to sort of train yourself to remember that fact. And so after, and then at the, if the user does enter in a negative value or 0, then we do skip over this. We skip over this assignment operation because of the if condition, but we still evaluate this. So if I is negative or 0, that will make this expression false. When that expression is false, we will continue executing the code or the program at the first statement following the loop. So we'll print the total, and that's the end. If it makes it easier for you to understand, you could put everything inside of a main function, and then return 0 from main. If that helps you understand what you're doing better. But I'm not looking for that on the midterm. So this would all be moved over like that. That's how it would look like if you were to code it up. If that helps you, solve the problem, you can do it like that. So here's a solution using an infinite loop where we do while true and break. The user inputs a value. If the value is a sentinel value, then we're going to break the loop. When this break runs, where do we go? Where do we go when we call break here? That's a statement. It causes a result. What is the result of calling break? Break means exit the containing loop. If you have a loop within a loop, it's the inner loop that you're going to exit, not the outer loop. So it's break means exit the closest, innermost containing loop that the execution is inside of. So when we break here, this is the end of the containing loop. So then we would go to print total. That's how we exit the loop. So this is a solution that uses an infinite loop. Here's another solution. This is, another one which uses a while loop. So you really wouldn't want to use a for loop here. I mean, you can though. You can. And this, oh, by the way, this do something. This would be, let's look at this. While the number is positive, see, we set it to some positive value just so that we enter the loop. It's a little sloppy. That's why I don't like this solution. And if I is a good number, I better quit soon here. Total, add it into total. And if it's not a good number, then we don't add it into total, and we'll come up to this condition here. We'll exit the loop, and then we'll print the total. Then we're done. Okay? So you might want to practice this a little bit on your own to get ready for the midterm. So when you get this kind of question, you'll be able to get an answer on paper. And look for a solution that makes sense to you. Something that you can use. Okay, that's it then. We're finished.
The rest of the midterm questions are on the YouTube video, right?
Oh, the other questions that we looked at before are in a previous lecture. I don't know which lecture was that. Lecture 8 or 9 or some lecture. Yeah.